In this video, I'm going to walk you through the post-lab for Lab 2 Hess's Law. There's a lot of data and a lot of calculations for this assignment. For question number 1, you're going to be reporting data and doing some calculations for reaction number 1 and reaction number 2. The balanced equations are provided here. So first thing I'm going to do is just go through and sort of mark the stuff that you'll be collecting in the experiment during the experiment. You'll be reporting the exact mass of NaOH. You'll get that from your balance. And then also the volume of the liquid, it says, in units of milliliters. The reason that it says liquid here, which is a little ambiguous, is that for reaction number 1, the liquid is going to be H2O. For reaction number 2, the liquid is going to be HCl. So depending on whether you're doing reaction 1 or reaction 2, you've got like a different liquid for each one of those. You'll be reporting that measured from a graduated cylinder. And then also during the experiment, you'll be reporting the initial and final temperatures. And then the rest of this is stuff that you'll calculate from that data. So the mass of NaOH you will have reported in units of grams, and then in this row right here, you're going to be doing a gram to mole conversion using the mass of the NaOH that you recorded from your balance. You'll be using the molecular weight of NaOH, which is about 40 grams per mole, and then just doing a straightforward gram to mole conversion. Now down here for the mass of the liquid, you'll be using the volume of the liquid, and you'll be assuming that your liquid has a density of 1 gram per milliliter, which is pretty accurate. So for this, you'll be doing a milliliter to gram conversion using the density as your conversion factor. 1 gram is 1 milliliter. And that milliliter of liquid is just going to be this number right here. Some students make mistakes in this spot because they see the gram and then they somehow want to incorporate the mass of NaOH. But this problem doesn't have anything to do with the NaOH. It's just about the liquid itself. And yes, it really is as simple, since it's a 1 gram per milliliter conversion. Whatever your volume is here, that's how many grams you're going to have. For your change in temperature, you'll just be using the equation final minus initial. Your final temperature, you reported right there, your initial temperature right here. And then you also want to make sure, this is going to be really crucial, that you are paying attention to your signs, exothermic and endothermic. So at this point, when you're doing this subtraction and getting your delta T, make sure that you have the correct sign. Now, next you're going to be calculating the total mass of the solution. The total mass of the solution is going to be the mass of the NaOH plus the mass of whatever liquid you're using. So either water or HCl. That'll be the mass of the liquid. The mass of the NaOH, which is this spot right here, and then the mass of the liquid, which you calculated right there. Combine them together. Next, you'll be calculating the heat of the solution in units of joules, assuming the specific heat is that of water, 4.184 joules per gram degree Celsius. You're going to be using your Q-SMAT equation to do this, Q SM delta T. The S has been provided to you right there. The mass is the total mass of the solution. So you want to take that combined mass that you just calculated, and then your delta T, of course, now I've got a lot of arrows going on here. Your delta T is the delta T that you calculated in this spot. Next, you'll be converting that heat into units of kilojoules. So here we're just going to be converting joules into kilojoules, which is just simply dividing by 1,000. And then last but not least, you'll calculate the delta H, or the change in enthalpy for the reaction. This is going to be taking your kilojoules and dividing it by the moles. The kilojoules that you just calculated and the moles, which are way, way, way up here, right there, the moles of NaOH. So there's a lot of stuff going on in this. You'll do the exact same thing for reaction number 2, exact same set of calculations. Now, once you get those done, you'll move on to the analysis for reaction number 3. This one is a little bit different. So first I'm going to go through and identify the stuff that you'll be recording while you're doing the experiment. You'll be writing down the volumes of your HCl and your NaOH. and you'll be writing down the initial and the final temperatures, and that's all that you'll be writing down. The rest of it is calculated. Starting with the moles of NaOH, this we're going to be using the molarity. So we're going to be using the molarity to convert from milliliters of NaOH into moles of NaOH. And this is one that we don't have a ton of practice with. So really, you might want to think about this as milliliters to liters, and then liters to moles of NaOH. And again, we'll be using the molarity as our conversion factor right there. That tells us that we have 1 mole of NaOH for every liter of an NaOH solution. So you can use your milliliters of NaOH and convert that into liters, and then use this conversion factor over here to convert it into moles. Once you get that done, you'll be calculating the mass of the HCl solution and the mass of the NaOH solution. This is the mass of the solution itself. So for these calculations, we're going to be only using the volumes and the densities, the assumed densities as well. This will be, for the first one, this will be the milliliters of the HCl solution converted into grams of HCl. The milliliters of the HCl solution will be this right here. And again, this is a 1-to-1 conversion factor. So however many milliliters you have, let's say it's 50 milliliters, that's going to be how many grams you have down here. Same thing for the NaOH. This is something that some students get confused by because they want to try to incorporate molecular weight in this one way or another. So this will be the milliliters of the NaOH solution, this guy right there, converting it into grams of NaOH using the density. Again, it's a 1-to-1 ratio. For your delta T, your change in temperature, this is going to be your final temperature minus your initial temperature, and I'll remind you again that you definitely want to be paying attention to the signs. Make sure that you get negative signs in place where they belong. I put that in the wrong box. That goes right here. The total mass of the solution is going to be the mass of the HCl solution plus the mass of the NaOH solution. The mass of the HCl solution you calculated right there, and the mass of the NaOH solution you calculated right there. Now we're going to do our heat calculations. First, we'll calculate heat in joules. That's going to be Q SMAT, SM delta T. The S, specific heat, is right here. We're assuming the specific heat of water. The mass is the combined mass that you just calculated, and the delta T, your change in temperature. Once you get that done, you'll take the joules and you'll convert them into kilojoules by dividing. And then the last thing that you'll do is calculate the change in enthalpy. That's going to be the kilojoules divided by the moles of NaOH. Kilojoules, which came from right here, and the moles of NaOH, which were calculated way up here, right there. So once you get all the calculations done, then what you're going to do is actually try to use Hess's law to come up with this number right here using your data from reactions 1 and 2. So in this step, what we've done is calculated the delta H for this reaction using the change in temperature, using the data that was collected for that experiment. What we're going to do next is see if we can use the data from reactions 1 and 2 to come up with another value, or hopefully the same value of delta H. So to help us with that, the first thing that we're looking at here are the 3 balanced equations for the 3 reactions that you performed in this experiment. Remember, our goal is reaction number 3. So this is like our goal or our target equation. And what you want to do is show how you can combine reaction number 1 and reaction number 2 to give you reaction number 3. So this is, where we practice adding equations together, and the result of that equation we want to be reaction number 3, NaOH plus HCl aqueous. Both of them makes NaCl aqueous, and H2O liquid. And so your job is to figure out how do you need to write reaction number 1 and how do you need to write reaction number 2 to give you this overall equation. Once you've got this figured out, like how you write reaction number 1 and how you write reaction number 2, you're also going to add the delta H values for those reactions that you calculated in problem number 1. So we're going to go back to problem number 1. The delta H values that you calculated, which are these guys right here, going to be these numbers right here, you're going to fit them in to problem number 3 in a way that makes sense. So that means if you took reaction number 1 and you just copied it exactly the same way as it is, that means you'll report the exact same value of delta H as you have in problem number 1. If you needed to take reaction number 1 and turn it around backwards, you know that that means you need to change the sign of delta H. If it was negative, you turn it positive. If it was positive, you turn it negative, and so on and so forth. So you know how to do that. And that's going to give you a new value of delta H for reaction number 3. So again, what we've done is calculated the delta H for this reaction using Hess's law. We've also calculated the delta H for that reaction using experimental data. In question number 4, you're going to report the 2 values of delta H for reaction number 3. One of those is the number that you calculated using Hess's law, right there. And the other one is the number that you calculated in problem number 2 using your experimental data. So that's going to be this number right here, using your changes in temperature. And then what you're going to do is figure out which one of these values you think, I guess I shouldn't say figure out, you're going to make a guess about which value you believe to be the most accurate. Now, I don't know which of these is the most accurate. It really depends. This is your opinion. Identify which value you believe to be the most accurate and then justify it. So, if you did this lab in person, and maybe you made a lot of mistakes when you were doing experiment number 3, maybe you spilled something or whatever, and you feel like this data is pretty bad, then you might say that you think that this number right here, which came from your data, you might say, I'm pretty sure that this is really inaccurate because I know I made a mistake. Or if you're doing this lab in person and you really messed up reaction number 1, then you might say that the data coming from reaction number 1 was probably pretty bad, and therefore the Hess's law calculation was pretty bad. If you did this lab online with Beyond Labs, then maybe you've got a similar thing, like maybe you didn't read the temperature correctly, maybe things ran for too long and you didn't get an accurate temperature measurement. So it's really just going to be based on what you experienced as you were doing the experiment itself, which is why I'm asking you to explain or justify why you made the decision that you did. You really can't screw this problem up as long as you answer the question with something.